Hello and welcome back to part 2 of applications of trig functions. In this video, we're going to pick up where we left off and look at a few more examples of what we can do. The first half of this video is going to have us look at some more abstract sort of triangle problems and see what we can do. So this one in particular is an example where instead of having our two triangles share a common angle, we're asking them to share a common side length. And we'd like to determine that side length. If you want to really test your abilities of what's going on here, I actually really do urge you to pause the video here and spend, maybe about 10 minutes or so really trying to figure out how you might solve for this length x. This is a really good challenging problem, and I think it would be a good idea for you to tinker with it yourself before watching me go through it. Or tinker with it yourself and then sort of watch me for a few seconds, and then once I do something a little bit different, pause it again and see if that's enough for you to get to the end. There are more than one way. There are many different ways to solve these problems. The way I'm going to do it is as follows. I'm going to introduce a dummy variable, say b, which is going to take the place of this base length for the smaller triangle. And what I'll notice is I can build a trigonometric relationship involving tangent for each of these triangles. And if I do so, I'll end up with tangent of 40 degrees is equal to just x over b, and the tangent of 20 degrees is equal to x over 400 plus b. And now here's where things are interesting. I have two equations with two unknowns. You know how to solve these types of equations because you've done them in the past. You might remember, for example, you used something like elimination and substitution. Elimination was a method that was very useful when your equations in question here are linear. In our instance, they're not linear, they're trigonometric and somewhat involving rational functions. So the alternate method, substitution, is actually going to be really useful. The way I'm going to start off is I'm going to eliminate the variable b via substitution. That way all I'm left with is x. And the way I'm going to do that is I'm going to take this first equation and I'm going to solve for b. So we know that b is therefore equal to x over the tangent of 40 degrees, which means I can take x over tan 40 and put that in wherever I see b in this other equation. So what I find is that the tangent of 20 degrees is equal to x over 400 plus b, which we now know is x over the tangent of 40 degrees. Now my objective is to take this complex looking fractional equation and solve for x. This is where you need patience and working through it slowly but surely. My recommendation would be to get a common denominator first for this fraction's denominator, and in doing so, you might get the following. Probably you'll get tangent of 20 degrees is equal to x over, you should get 400 times tangent of 40 degrees plus x all over tangent of 40 degrees. The numerator, x, can be rethought of as just x over 1. So the right-hand side is just a fraction divided by a fraction. So you can use keep, change, flip in order to rewrite that right-hand side or the overall equality as tangent of 20 degrees is equal to, in this case, we're going to get x times the tangent of 40 degrees all over 400 times the tangent of 40 degrees plus x. Where now I'm going to multiply this denominator over to the left-hand side, and then I'm going to have to distribute this tangent 20 to each of those terms. So to write that, I'm going to get tangent of 20 degrees times 400 tangent of 40 degrees plus x is equal to x times the tangent of 40 degrees. Distributing that tangent, I will end up with 400 times the tangent of 20 degrees times the tangent of 40 degrees plus x times the tangent of 20 degrees is equal to x times the tangent of 40 degrees. And now we're literally almost done. Here we have some sort of just a number right here, and then we have a term with an x and a term with an x. So we've seen this technique used before. I'm going to move this x over to the right-hand side, factor out the x, and divide by what's left over. And what you should end up with is x is equal to, it's going to be equal to 400 times the tangent of 20 degrees, tangent of 40 degrees, all over the tangent of 40 degrees minus the tangent of 20 degrees. And that's going to be our final answer. Now, there's other ways you could have solved this problem, and if you did it a different way and you want to check to see if you got the correct answer, you could compute all of this on a calculator or a computer, compute your answer you got on a calculator or a computer, and verify that you get the same answer at the end of the day. But this somewhat complicated looking process is sort of a bulletproof, surefire way to help solve this problem. We can do a slightly different take on this problem by encountering this situation. Here we know the vertical length and we want to find one of the horizontal lengths. We can approach this similarly. We can call the missing length b, and we can build some tangent relationships. We'll get, say, tangent of 34 degrees is equal to opposite 300 over adjacent, which is x plus b, as well as the tangent of 64 degrees, which is going to be opposite over adjacent b. Now again, we have two equations, two unknowns. Our goal is to solve for x, so I'm going to take the second equation. Well, there is actually a somewhat difference. Maybe I misspoke. Here what we'll notice is that the second equation actually doesn't have any x's in it, whereas this one, both equations had both unknowns. So this question here is going to be a lot simpler to solve. What we're going to do is we're going to take the second equation, we're going to solve for b. b is apparently equal to 300 over the tangent of 64 degrees. And so what that means is that if our goal is to solve for x, we'll take this first equation, move that x plus b over to the left-hand side. We're going to get x plus b times the tangent of 34 degrees is equal to 300, which after we distribute the tangent, we get x tangent of 34 degrees plus b tangent of 34 degrees is equal to 300, which means now if I take this term without the x and move it to the right-hand side, I'm going to end up with x tangent of 34 degrees is equal to 300 minus b tangent of 34 degrees, which then if I divide, I get x is equal to 300 minus b tangent of 34 degrees all over tangent of 34 degrees. Where now we can substitute in this b value we found right there, which gives us a final conclusion of x is equal to 300 minus 300 over tangent 64 degrees multiplied by tangent of 34 degrees all over the tangent of 34 degrees. A couple of key notes here that you may or may not have observed as I write out all my math is that I always put parentheses around my trig functions. And since all of these are in degrees, I've written degrees every single time. Because remember, if you don't write that, I'm going to assume that your angle is given in radians, and you're going to get an incorrect answer. Now, the last page here we have here is basically more practice. So the first question here involves a television transmitting question on angles of elevation. And so this is a lot like the Eiffel Tower problem. This next question involves the Statue of Liberty, and we have an angle of elevation from the ship to the top of the statue. We want to know how far is the ship from the statue's base. We've done a lot of problems that are sort of similar to setting that up. Maybe we'll draw a quick picture just to make it clear what we're doing here. Well, no, I'll let you all try that at home, and if you have questions, I urge you to send me an email and let me know. The last question we have here is a wheelchair ramp being built beside the steps of a campus library. Again, this is similar to the right here, it's very similar to the guy wire one. Because if we draw the picture here, what we're told is that a wheelchair ramp is built. Find the angle of elevation of a 23-foot ramp. So it's a 23-foot ramp. We have some sort of an angle of elevation, theta, and the final height of the ramp is 6 feet. So you can recognize this is very similar to the guy wire problem. So I'll leave these last 3 examples for you to tackle at home, and if you have any questions, you can send me an email and show me your work, and I'm happy to take a look at it and provide pointers in the right direction, or just straight up check your work as well. But this is going to wrap up our conversation in section 4.8, and actually wrap up our conversation all of chapter 4. And so what we've done so far is we've successfully introduced the notion of trigonometry. We've defined angles and their measurements. We've talked about the basic trig functions. We learned how to graph them and when their inverses exist and what they look like. And now we've talked about how to solve real-world problems using trigonometry. In the next chapter, chapter 5, we're going to do the following. When we talked about this problem right here, this complicated problem, I mentioned there's many different ways to figure out what the correct answer is. The way I did it yielded an answer that looks a lot like what we have down here, but there's other ways you could conclude the same exact result, and it's going to look slightly different. I have some tangents, and you could have developed this entire thing with similar triangles utilizing, I think it's sines. And the question is, if you can get this in 2 different ways, but you get the same exact number, then what that means is that some trigonometric formulations look very different, but are actually equal once you evaluate them all. These types of situations are referred to as trigonometric identities. We've already encountered a few of them, Pythagorean identity, for example. We're going to spend the remainder of the semester basically trying to discuss trigonometric identities in more detail, and then seeing how we can use them to solve trigonometric equations. But for now, we're going to finish up our conversation here in section 4.8. So tackle what you can of the homework. Let me know if you have any questions. Send me emails. But otherwise, I will catch you all in the next one.